One skill that's useful is being able to identify quickly whether some equations that are definitely not in standard form, like these screwy things over here, are a circle or hyperbola or ellipse or parabola, without having to go through the whole completing the square procedure to make them look nice and pretty, like all these standard form equations I got on the right side. Okay, we're not going to change these into the standard forms. We're just going to look for clues. So here's an example. Parabola, first clue that I'm looking for. There's an x squared or a y squared, but there is not both. Okay, and if you look through this list, you'll see, hey, this guy's got an x squared and it's got a y squared. Okay, so that's not a parabola. You can go through the whole list. The only thing you're going to find without both x squared and y squared is this guy. Okay, so that's my parabola right there. Okay, next clue. The circle's an easy one to spot. If you're looking at circles, you're going to notice they have the same sign of the x squared and y squared and the same number in front of it. There may not be any number, or there may be a number, but it has to be the same, like 2 and 2. So look through this list. There are going to be some examples, like this one, where it's a -7 and a -7. They're both negative, okay? That checks one box, and they're both the same number, 7. So that is my first circle right there. And keep on looking through the list, see if you can find another one before me. I see a few things in here that have the same sign, but they're different numbers, like this guy, -8, -7. That is not a circle. Those need to be the same number in front. So we'll get to that guy next. Are there no more circles? Oh yeah, there's one. There's one at the very end. 10 and 10 for the x squared and y squared. So that's another circle at the bottom. Now the ellipse is an interesting one. It's a lot like a circle. In fact, a circle is just a type of ellipse. But the giveaway for an ellipse is it has different coefficients. Okay, not the same coefficients like in the last one. They have the same sign, but they're different numbers. So let's see if we can find one. Here's an example. See this guy? -y squared, 8y squared. And this one over here, -7y squared. Okay, those are the same sign, but they're different numbers. So that's going to be an ellipse. And then any others? Here's one. +6, +2. Both positive numbers, so they're an ellipse, even though, well, we'll get into the hyperbola next. Last one, hyperbola. Now, this one's actually a little easier to spot than the difference between circles and ellipses, because that's minor. All you have to look for is a sign, a plus or minus sign that's different between the x squared and the y squared. If you see a different sign, I don't care about the number in front of it. It's the difference in the sign that matters. So for example, this guy, -2y squared, +4x squared. That's a hyperbola because the signs are different. It's plus and minus. Here's another example. +4, -4. Don't get tricked into thinking that's a circle because those numbers are the same. Because the sign is different, it's a hyperbola. Now, one thing I did not get to in this discussion is the orientation of these shapes. Like, are they vertical or are they horizontal? Are they taller or wider? That's not something you can tell so quickly from just glancing at the equation, but you can tell what kind of a shape it is you're dealing with in general.